Welcome back, everyone. Now, in this video, we're going to talk about the difference between degrees and radians. So this is going to be a different way of how we're going to measure angles in trig. So more specifically, you guys are used to measuring your angles in terms of degrees. So if I give you an angle that's, say, 30 degrees, 60 degrees, 90 degrees, so on and so on. Well, now we're going to look at a different unit of measurement. So just to kind of give you a backstory, just like how you measure distance in, say, miles or kilometers, meters, feet, inches, centimeters, it's kind of the same idea. Instead of measuring degrees, the new unit of measure we're going to talk about is called a radian. So the warm-up is just kind of a recap of solving right triangles. I'm going to let you guys kind of peruse over that as needed. So then, looking down here, we're going to look at what we call a radian. Now, a radian is going to be the degree of the central, or not degree, is the central angle measure when the radius is equal to the arc length. So meaning if I look at this diagram here, the angle formed is going to be equal to the arc length. Now that measure is what we call the radian. So around a circle, which this isn't going to work as well as like a graphic interchange, which I did upload online so you can kind of see if you're on my Schoology page. But if I look at a circle, then I have this measure here. This would be 1 radian. And then the next one would be 2 radians. And then the next one would be about 3 radians. And then if I go straight across this tiny little sliver, notice how now it forms 180 degrees. And then this part right here is actually going to be just a small little part, more specifically 0.14 radians. So if I go all the way around, and if I have 3.14 radians, this is equivalent of saying pi radians. And then if going halfway is pi radians, if I go all the way around, then that would be 2 pi radians. So that's kind of a idea. I would say a graphic that I have uploaded is going to be a little bit more specific, but I digress. So what we're going to focus on first is just looking at the conversion between a degree and a radian. So looking at degrees to radian, we're going to take a degree measure that's given to us, and we're going to multiply by pi over 180 degrees. Now, if you notice back up here on this little graphic that I did, halfway across the circle is pi radians. But if I have a straight line, a straight angle here, this is also the equivalent of 180 degrees. So pi radians and 180 degrees is actually the same thing. It's an equivalent measurement using a different metric. So this kind of goes into conversion properties. And then same idea over here. If I'm given a radian and I want to go to degrees, it's the degree over the radian, and then we're going to multiply the radian by that value. So just to kind of show you, first off, we're going to start with 30 degrees. So 30 degrees, I want to convert that to radians. So I'm going to do 30 times pi over 180 degrees. And this is going to be equal to 30 pi over 180. And then you're going to simplify, and that's going to become pi over 6. So pi over 6 radians is the same as 30 degrees. Now, if you want to be a little bit more specific in how we do this, I know you guys kind of cover this in, I believe it's called stoichiometry in chemistry, but let me write this out a little bit differently. So if I do 30 degrees, and I want to convert this to radians, I would do pi radians over 180 degrees. And then what's going to happen, the 30 degrees over here, this is just over 1. Your degrees are going to simplify, so I'm left with 30 pi radians over 180, which is just going to simplify to pi over 6 radians. So that's if we want to look at the units in particular, but we're going to kind of not dumb it down, but we're just going to write it in a little bit more of a simple way. So now I want to convert pi over 4 in terms of degrees. So pi over 4, I'm going to multiply this times 180 over pi. So this is going to be 180 pi over 4 pi. Your pi's are going to simplify, and then we are left with 180 over 4, which in this case is going to be simplifying to 45 degrees. So pi over 4 radians is the same as 45 degrees. Okay, so I would say pause here, take some time, fill out the rest of this table, and then I'm going to speed run this, or hopefully speed run it. So 60 degrees when you do your conversion, this is going to be pi over 3. Pi over 2 is going to be the same as 90 degrees. 120 degrees is going to be the same as 2 pi over 3. 3 pi over 4 is going to be the same as 135 degrees. 150 degrees is going to be the same as 5 pi over 6. And then pi radians is the same as 180 degrees, as we talked about earlier. Okay, and then we're just going to continue. We're going to do a bunch more. So 210 degrees is going to be the same as 7 pi over 6. 5 pi over 4 degrees is going to be the same as 225 degrees. 240 degrees is going to be the same as 4 pi over 3 radians. That's a 3. 3 pi over 2 radians is the same as 270 degrees. 300 degrees is going to be the same as 5 pi over 3 radians. 7 pi over 4 radians is going to be the same as 315 degrees. 330 degrees is going to be the same as 11 pi over 6 radians. And then 2 pi all the way around is going to be 1 full revolution, which is 360 degrees. So, of course, ideally, you should show your computations that lead to the conversion in each step, but we'll get more into that later. So now down here, this is just to kind of familiarize with what we're about to do. It's called the unit circle. The unit circle is going to be the next lesson, but we're just going to kind of slowly transition into it. So what we're going to do is we're going to be given kind of a skeletal framework of all these degrees in radians. So for the first one, this first little picture here, we're going to do all the positive degrees from the first page. So when I say positive degrees, what's going to happen is we're going to start at 0 degrees. So if I start at 0, I know I might be getting a little ahead of myself. Let's actually pause here. Let's actually go down here. Let's talk about measuring angles, and then I'm going to come back, because I don't want to get too ahead of myself. So when we're measuring angles, so we're going to look at what we call an angle in standard form, or standard position. So standard form, standard position, it's going to be the same idea. So that is going to be when the vertex is at the origin in one side, which we call either the initial or the terminal side, is on the x-axis. So what's going to happen is we're going to look to see where we start, which is the initial side, and then where we end, where we're going, which is what we call the terminal side. And that's going to pivot around the point that we call a vertex, which oftentimes when we're measuring these angles in a circle, this is going to be at the origin. So this is what it's going to look like. We're going to have the initial side, which is going to start on the positive x-axis. So we're going to start over here, and then we're going to rotate counterclockwise until we get to what we call the terminal side. The terminal side is where it's going to stop. And then that arrow right here in the middle is going to dictate the direction that we're going. Whoops. So knowing that, now we're going to look at what we call positive and negative angles. So if we have a positive angle, we're going to be rotating counterclockwise. So we're going to go up to the left. And if we have a negative angle, we're going to rotate clockwise, which is going to be down to the right. So now that we know measuring these angles, now I'm going to come back up here and we're going to graph these. Or graph, plot, tomato, tomato. All right, so when we're graphing or plotting these angles, we're going to start in standard position. So when I say standard position, that's going to be the positive x-axis side right here. This is where you're going to start. So when I start and I want to plot these positive angles, we're going to be going counterclockwise. So the first angle that we have is going to be at 0 degrees. And then when I go up the next, that's going to be 30 degrees. And then we're going to go up to 45 degrees. And then up to 60 degrees. And then when I go straight up on the y-axis, that's 90 degrees. So that would be your first quadrant. So now I'm going to do the other 3 quadrants. So this is going to be 120 degrees, 135 degrees, 150 degrees, and then when we are straight across, we have 180 degrees. Then in quadrant 3, so now we have 210 degrees, 225 degrees, 240 degrees, and then 270 degrees when we're on the negative y-axis. And then we're going to 300 degrees, 315 degrees, 330 degrees, and then when we come all the way back, then we have 360 degrees for a full rotation or a revolution. So anytime I measure these angles in standard position, we're going to start on the positive x-axis, and then we're going to go however far to get to the terminal side. So it could be whichever one of these angles, and that arrow is going to dictate where we stop. Okay, so now that's the positive angles. So now we're going to come over and we're going to do the negative angles. So negative degrees. So over here, once again, we're still going to be starting on the positive x-axis with, I'm having a stroke. This is your initial side. This is where we start, and we're going to be starting at 0 degrees. So if I were to do negative, then we're going to go clockwise. So now I'm going to go down. So with clockwise, now we have negative 30. Then we're going to go to negative 45 degrees, then negative 60 degrees, negative 90 degrees. That's a 90. Then negative 120, negative 135, negative 150, and then over here we're going to have negative 180 degrees, which is going to overlap and be the same as positive 180. Okay, and then as I keep going, so then this would be negative 210 degrees, then negative 225 degrees, negative 240 degrees, and then we're going to have negative 270 degrees on the positive y-axis. Okay, and then as I keep going, then we have negative 300 degrees as we venture into quadrant 1, and then negative 315 degrees, negative 330 degrees, and then that's going to venture all the way to one rotation, one revolution, which is going to be negative 360 degrees. So notice how we're always going to start on the positive x-axis, and then we're going to rotate or go around either clockwise or counterclockwise, depending on if it's positive or if it's negative. So just like I did before, your arrows, starting from the initial side going to the terminal side, is going to dictate the length in that angle measure. So if I want to show negative 60 degrees, I'm going to show the angle or the arrow going down to the negative 60. And if I want to show negative 120, then I would go from the start all the way to negative 120, show that arrow, and then you're going to stop at wherever that terminal side is that you want to measure. So those arrows that you draw are going to be very important. So now we're going to do the same idea down here, but now we're going to do the radians. Now I will say, now that you're learning about radians, the radians are going to be way more important. So starting off, we're still going to be starting in standard position, which means we're starting on the positive x-axis. So I'm still going to start measuring from here. From what I've seen, we will not measure starting from anywhere else when we're measuring these angles. So I'm still doing my positive angles, which means I'm going to be going counterclockwise. So my first radian, well, we're going to start at 0 radians, and then we're going to go up to 30 degrees, which is pi over 6 radians, and then pi over 4 radians, pi over 3 radians, and then your 90 degrees is going to be equivalent to pi over 2 radians. And then we're going to have 2 pi over 3 radians, 3 pi over 4 radians, and then 5 pi over 6 radians, and then all halfway across is going to be pi radians, which is 180 degrees. And then as we keep going, so now we have 7 pi over 6 radians, 5 pi over 4 radians, then we have 4 pi over 3 radians, and then at the very bottom down here, we're going to have 3 pi over 2 radians. Then in quadrant 4, so 5 pi over 3 radians, then 7 pi over 4 radians, 11 pi over 6 radians, and last but not least, a full rotation, full revolution, which is going to be 2 pi radians, which this is going to go into that diagram or that graph that I tried to draw up here. So when I go halfway around, that's just pi radians, but when I go all the way around, it's 2 pi radians. So there's the positive radians. Now, same idea. We're going to do the negative radians, which means we're going to be going the other way. So once again, we're starting in standard position, which means we're starting on the positive x-axis. You're going to start measuring your angles from here. So you don't have to write the start. I just like writing start here just so that you guys know where we're going to be measuring from. So with a negative angle, that means we're going to be going clockwise. So your angle here. So now we're going to be looking at 0 radians as we start, and then negative pi over 6 radians, negative pi over 4 radians, negative pi over 3 radians, negative pi over 2 radians, negative 2 pi over 3 radians, negative 3 pi over 4 radians, negative 5 pi over 6 radians, negative pi radians, negative 7 pi over 6 radians, negative 5 pi over 4 radians, negative 4 pi over 3 radians, negative 3 pi over 2 radians, negative 5 pi over 3 radians, negative 7 pi over 4 radians, negative 11 pi over 6 radians, and then all the way back to negative 2 pi radians, which is where we start. So I would definitely make sure that you are good with knowing where each and every single one of these both positive and negative angle values are in both degrees and radians. That's going to help you a ton when we get to future lessons, namely when we get to the unit circle in the next one. All right, so as we already talked about with measuring angles, now we're going to just measure individual angles. So we're going to be given these circular graphs, and then you are going to sketch the angle measurement in standard position. So if I have 45 degrees is going to be in quadrant 1. So what's going to be important is knowing where each of these angles are going to be in terms of quadrants. So that's why I put this page up here in front of everything else, just so that you have some sort of reference. So as a recap, quadrant 1 is going to be in that top right, quadrant 2, top left, quadrant 3, bottom left, and then quadrant 4 is going to be that bottom right. So you need to know where these angle values are going to fall in terms of which quadrant and in terms of which angle measurement we're using, whether we're using degrees or if we're using radians. So if I have 45 degrees, that's going to be between 0 and 90, which tells me it's going to be in quadrant 1. So that's going to be halfway between 0 and 90. And then you are going to be required to sketch an arrow to signify which direction we're going. Because if you don't, how do I know I'm going counterclockwise versus clockwise? So putting the arrow is part of what we're looking at. So we're going counterclockwise since we're positive. So 3 pi over 4, that's going to be in quadrant 2. So that's going to be over here. And then we're going to draw your arrow going to 3 pi over 4 since it's a positive angle. Then negative 90 degrees, that's going to be going straight down from 0 in standard position. So your arrow, you're going to start it in standard position and then going clockwise to the terminal side. And then pi over 3, that's going to be in quadrant 1. So that's going to be up here a little bit closer to pi over 2, which is 90 degrees. And then you're going to draw your arrow going up. So, of course, I've been doing this for 20,000 years, so I know you guys are probably like, how the heck does he know where these angles are? You're probably going to want to reference these 4 graphs a lot, which is totally okay when we first start. As you use these graphs more and more, you're going to become more acquainted and more comfortable with knowing where these angles are. So this is just going to be a very slow, tedious process for you when you first start out, and that's okay. Just like when you first learn to ride a bike, you're going to scrape your arms and knees. You just got to keep going. All right, so with 120 degrees, this is going to be in quadrant 3. It's going to be a little bit closer to the vertical axis than the horizontal axis. So you're going to draw your angle going counterclockwise. Whoops. Okay, and then number 8 is 11 pi over 6. That's going to be quadrant 4. It's going to be closer to the x-axis than the y-axis, and it's still positive, so I'm going to draw going counterclockwise. Okay, then negative 40 degrees. So that's going to be going clockwise since it's negative, and it's going to be going downward. And then we want your angle to go down like this. Okay, and then we have what we call, hello. We just have negative 5 pi over 4. Because it's negative, we're going to be going clockwise. Now, that's going to go to the second quadrant. But because we're negative, it's going to be going through this way. All right, and then I made this last row of problems a little bit more annoying on purpose, just to kind of introduce what we're going to do in the next section. So for this first angle that we have here, it's 560 degrees. Well, if you think about the circle that we just did, we have a total of 360 degrees. So we're going to have to get a little creative with how we show this. So what I want to do is I'm actually going to take away one full rotation. So I'm going to take away and subtract 360 degrees. So when I subtract, we're left with 200 degrees. So 200 degrees, if I were to graph this angle, that's going to be a little past 180, which is going to put us in quadrant 3. But when you draw your rotation to show 560, that's one full rotation. So one full rotation. Actually, I'm going to say revolution. And then a little bit more with the 200. So what that means is when we start in standard position, I'm going to go one full rotation and then go more. So you're going to show a good amount of spirals. Okay, now for the next one, now we have 17 pi over 6. Now this is more than one rotation, because if you think about 2 pi, and then I get a common denominator of 6, that would be 12 pi over 6. That's the same as 2 pi. So what I want to do, same idea, is I want to take away 2 pi, which means I'm going to take away one full rotation. So I'm going to do 17 pi over 6 minus 12 pi over 6, which is going to be equal to 5 pi over 6. So in terms of the terminal side of the angle, we're going to plot it at 5 pi over 6, which is in quadrant 2. But to show an additional full rotation that we took away, we're going to have to go around the whole circle at least once. So around the full rotation, and then a little bit extra to show the extra 5 pi over 6. Okay, and then over here we have negative 400 degrees. So it's going to be the same idea. We're going one full rotation, but in the clockwise direction. So to counter it, I'm actually going to add one rotation. So negative 400 degrees plus 360 is going to give me negative 40 degrees. So negative 40 degrees is going to be down here in quadrant 4. And then because we're doing a negative rotation, or a negative angle rather, I'm going to go clockwise. So you're going to show one full rotation and then some. There we go. So make sure when you're drawing your arrow, you're starting on the positive x-axis, which is in standard position. I've seen some people draw it from the angle. Well, you don't want to do that. You want to start from standard position, which is the positive x-axis. Okay, and then over here, so now we have 22 pi over 4. This is going to be a few rotations. So first thing I want to do is I want to get 2 pi with a denominator of 4, which means I'm going to multiply the numerator. That'd be 2 pi over 1. So I'm going to multiply the numerator times 4, which is going to be 8 pi over 4. That's 2 pi. So I'm going to subtract 2 pi, which is going to be the same as subtracting 8 pi over 4. So I'm going to take away one rotation. So taking away one rotation is going to give me 14 pi over 4, which that's still more than one rotation. So I'm going to take away another rotation of 8 pi over 4. So taking that away is going to give me 6 pi over 4, which when I simplify, that's going to be equal to 3 pi over 2. So that tells me my terminal side is going to be at 3 pi over 2, which is straight down. But then when it comes to drawing your arrow in standard position, we have 1 and 2 full rotations that we have to do. So drawing your spiral on this one's going to be a little fun. So we're positive, so we're going to go counterclockwise. So I'm going to go 1, 2 full rotations, and then some. So that would be your spiral for 22 pi over 4. Okay, so now that we're done with sketching, now we're going to look into different types of angles. So the first type of angle is going to be what we call coterminal angles. Coterminal angles are just angles that share the same initial and terminal side. Y'all, I cannot stress this enough. Coterminal angles are going to be so important for a later topic, as in people don't remember what coterminals angle are by the time we get to the future topic, so people have to relearn a previous topic in addition to learning the new topic. So it makes that topic super difficult if you don't remember what coterminal angles are. So just throwing it out here now. I know it doesn't mean much coming from me as a math teacher, but oh my goodness, coterminal angles are one of the most important concepts in pre-cal. So in this case with coterminal angles, we're learning how to use the tool before we actually use the tool. You don't just use a power drill on something. You have to learn how to use the power drill. It's the same idea here. We're learning how to use the power drill before we actually use the power drill. So with coterminal angles, they're just angles that are going to look the exact same. So just to kind of give you an idea, coterminal angles, if I look at these radian values over here, if I look at pi over 4, notice when I did the negative angles, negative 7 pi over 4 is in the same place. These two angles would be what we call coterminal. Same idea with pi over 6 and 11 pi over 6. Those are coterminal. They're in the same place when I graph them, but they're measured using a different angle. So same idea, 2 pi over 3, negative 4 pi over 3, 7 pi over 6, negative 5 pi over 6. All these angles that are in the same location are what we call coterminal. And it's the same idea in degrees. So positive 60 degrees is the same as negative 300 degrees. So if I were to plot 60 degrees, I would go counterclockwise. But if I want to show negative 300 degrees, I would go clockwise. So they would end at the same place. So same idea if I'm looking at 135 degrees. So the same place would be negative 225 degrees. So if I start in standard position going to 135 degrees, this would be my terminal side, but then a negative angle would be here at also 135 degrees. They share the same terminal side. So 135 and negative 225 degrees, these are what we call coterminal. So with that, in order to find coterminal angles, what you're going to do is if you're in degrees, you're going to add or subtract 360. And if you're in radians, you're going to add or subtract 2 pi. Which, remember, this is just a fancy way of saying 1 revolution. 1 full rotation, 1 revolution, however you want to say it. So we're going to sketch the following angles in standard position, and then down below on the next page, this is where we're going to find the coterminal angles. Now, with what I said in the directions here, we're going to find 2 positive and 2 negative. We're going to find 2 of each, so 4 total. So if I have 60 degrees, 60 degrees is going to be here in quadrant 1. So that's going to go in standard position, which means we're going to go, or a positive angle in standard position, which means we're going to measure it going counterclockwise. Now I want to find the coterminal angles. So we're in degrees, so I'm going to add and subtract 360. So for positive, I'm going to add 360. So when I add 360, that's going to give me 420 degrees. That was not intentional. Okay, and then I want to find another coterminal. So I'm going to take that 420 degrees, and I'm going to add another 360. So if I add 360, that's going to give me 780 degrees. And with coterminal angles, what you can do is there's no limit. You can just keep adding 380. So if I wanted to, I just told you to find 2, but I could technically tell you to just keep going. So 780 plus 360, that'd give you 1,140. If I wanted you to keep going, so then 1,140 plus 360. So that'd be 1,500, if I do math correctly. So like I said, it's just going to keep going. There's no limit to how many coterminal angles you can find. But I'm just going to have you find 2. Okay, now for the negative coterminal, instead of adding 360, now we're going to subtract 360. So when I subtract, that's going to give you negative 300 degrees. And then we want to keep going. So negative 300 minus 360 which is going to give you negative 660 degrees. And then once again, you can keep going, but I'll just stop there. All right, and now we're going to jump over to 2 pi over 3. So 2 pi over 3 is going to be in quadrant 2. So in standard position, it's a positive angle, so we're going to go counterclockwise. So that would be your arrow that you would show. So now I'm ready to find the coterminals. So for 2 pi over 3, for a positive coterminal, I'm going to add 2 pi. So I need to get a common denominator. So this is going to be 2 pi over 3 plus 6 pi over 3, which is going to give you 8 pi over 3. And of course, we're just going to keep going. So 8 pi over 3 plus 2 pi. I'm showing out step by step. I'm not saying you have to, but I am. So 8 pi over 3, and then plus another 2 pi, which we're going to convert and rewrite it as 6 pi over 3. And then this is going to be rewritten as 14 pi over 3. So there are your 2 positive coterminal angles. Now I'm going to shift gears, and now we're going to find the negative. So 2 pi over 3. And then I'm going to subtract 2 pi. So I'm going to take away a rotation, or rather do a rotation in the negative direction. So this is going to be 2 pi over 3 minus 6 pi over 3, which is going to give you a negative 4 pi over 3, which 2 pi over 3, negative 4 pi over 3, I'm going to show you on that diagram. So 2 pi over 3, negative 4 pi over 3. They are coterminal. So if I measure counterclockwise, we get 2 pi over 3. If I go clockwise, we get negative 4 pi over 3. They are going to share the same terminal side. Okay, now just to keep going. So we have negative 4 pi over 3. And then I'm going to subtract 2 pi again. So negative 4 pi over 3 minus 2 pi, which we're going to rewrite as 6 pi over 3, which is going to be negative 10 pi over 3. So there are your 2 negative coterminals. Okay, so the others are just going to be more practice. So I'm going to move on from coterminal. We're going to look at the next type of angles, which is going to be reference angles. Now, reference angles, just like coterminal angles, they're going to be super important later on, especially when we get to what we call vectors towards the end of the year. We're going to be using reference angles a lot. So like I mentioned before about coterminal, people struggle with coterminal and reference angles further on in the course just because they forget that these concepts exist. And when I just randomly bring them back, people are like, huh? What just happened? So just know, I'm going to just put it out there right now. These are coming back. This is not something that you just want to put on the back burner and just let yourself forget. These are coming back. So with reference angles are going to be the acute angle formed by the terminal side and the x-axis. And then another important note is reference angles are always positive and acute. So positive regardless of the quadrant that it's in, and then they're always acute angles, as in your angle value is going to be between 0 and 90 degrees. If you get a reference angle that is, say, 110, you did something wrong. Okay, so with your reference angles is simply measuring the distance from the terminal side to the x-axis. That's kind of the short, mundane, layman's terms of writing it. So I'm going to do a little graphic here. So I'm going to show you an angle, say, in quadrant 1, angle in quadrant 2. These are just random angles. These are going to be drawn like this on purpose. And then let's do quadrant 4. Let's distort it just a little bit. All right, so quadrant 1, we have quadrant 2, quadrant 3, and quadrant 4. So when I show you these reference angles, it's always going to be measuring the distance from the x-axis. So from the x-axis, let's do it in yellow. From the x-axis to the terminal side of that angle. So if I'm looking in quadrant 1 here, I'm looking at this angle right here. This would be my reference angle. Now the reference angle is going to be denoted with a theta with an apostrophe. So I call it theta prime. So theta prime is going to be right there in quadrant 1. Quadrant 2 is going to be measuring from the x-axis to the terminal side which means we're looking at this angle right here as your reference. And then in quadrant 3, from the x-axis to the terminal side, so we're looking at this angle right here is your reference angle in quadrant 3. And then in quadrant 4, from the positive x-axis to the initial side, not initial, sorry, from the positive x-axis to the terminal side, this angle is your reference angle. So down here, notice that there's only 3 diagrams. I have diagrams for quadrant 2, quadrant 3, and for quadrant 4. Now that's because if I'm looking in quadrant 1, the reference angle is the actual angle. So just know the actual angle is going to be theta, the reference angle is going to be theta prime. So in quadrant 2, if I want to find the reference angle right here, which is going to be my theta prime, what I'm going to do is I'm going to take my angle and I'm going to subtract it from either 180 degrees or from pi. So my rule here, so my theta prime is going to be either 180 degrees minus the angle, or if I'm in radians, it's going to be pi minus theta, which is your angle. Okay, and then if I'm in quadrant 3, that means I want to take the full angle here and I want to get rid of quadrants 1 and 2. So with that, what that means is my reference angle is going to be equal to the angle itself, so theta minus 180, or theta is equal to, or theta prime is equal to theta minus pi if we're in radians. And then in quadrant 4, so I want to measure just this angle right here, which is your theta prime, which means I want to get rid of the rest of this. So I want to do the full rotation of 360 minus the actual angle itself. So your theta prime here, which is your reference angle, is going to be equal to either 360 minus the angle for in degrees, or it's going to be 2 pi minus your angle if we're in radians. So those are your formulas. I try not to stress the formulas too much. I try to tell you guys to look at it and think of it logically so that you're not just memorizing, you're actually understanding. But I know that's going to be kind of a tedious process. All right, so starting off, we're going to plot the angle measurement in standard form, then you're going to find the reference angle. So 150 degrees, that's going to put you in quadrant 2. So in quadrant 2, well, that's actually going to be about down here. So your reference, or no, not your reference, your theta value is going to be 150 degrees. So I want to find the reference angle. So the reference angle is going to be the distance from the x-axis to the terminal side. So this is going to be my reference angle. So what that means is I want to take my angle away from half a rotation. So that means my reference angle is going to be 180 degrees minus 150. So that means my reference angle in this case is going to be 30 degrees. Or another way you could ask yourself is, how many more degrees do I need to add to this in order to make it 180 degrees? That's another common way that I've been asking this, which helps people. Okay, now 5 pi over 4. So 5 pi over 4 is going to put you in quadrant 3. Okay, so if I plot this in standard position, that's going to be this angle over here. But if I want the reference angle, I want the distance from the x-axis to the terminal side, which means I want this angle. That would be my reference angle. So in quadrant 3, in order to find the reference angle here, I'm going to take the full angle that I have, which is 5 pi over 4, and I want to take away I want to take away the half rotation so that I just have this part left. So if I take away a half rotation, that means I'm taking away pi. So essentially another way you could ask yourself is, how many degrees do I need to take away, or not degrees, how many radians do I need to take away from this angle to get to pi radians? So, meaning I'm going to do, whoops, this should be theta prime, 5 pi over 4 minus pi, and then this is going to be 5 pi over 4 minus 4 pi over 4 when you get a common denominator. And then that tells you that your reference angle is going to be pi over 4. I didn't write it over there, but it's fine. Okay, so I would say you guys try 21, 22, and then we're going to practice. So with 315, so 315 degrees, that's going to put you in quadrant 4. It's going to put you about over here. So when I graph this, this is going to be standard position going counterclockwise. And then my reference angle is going to be from the x-axis to this side. So this side right here, this angle, is my reference angle. So to find the reference angle, your theta prime, because I'm in quadrant 4, I'm going to do 360 degrees minus 315. So another way you could ask yourself this question is, how many more degrees should I add to 315 to get to a full rotation of 360? So in this case, when you subtract, you're going to get 45 degrees. Okay, and then 22, 5 pi over 3, that's also going to put you in quadrant 4. So I'm going to put you down here. So your angle in standard position is going to go this way, but I want the reference angle, which is going to be this angle right here. So same idea. So that's going to be theta prime is going to be equal to the full rotation minus your angle, which is 5 pi over 3. So your reference angle is going to be 6 pi over 3 minus 5 pi over 3, which is just going to give you a reference angle that's equivalent to pi over 3. Okay, so down here, this is just kind of extra practice. This is just kind of tying it all together. I do want to do, I'm going to focus on the radian values because the radian ones are going to be way more important. So let's go ahead and do 23. So 23, 5 pi over 6, that's going to be over here in quadrant 2. So when I measure this angle right here, this is going to give you 5 pi over 6. And then find a reference angle. That's going to be this angle right here. So essentially, how many more radians do I need to get a full radian of pi? So in this case, this is going to be equal to pi minus 5 pi over 6, which is equal to pi over 6 radians. Now I want to find some coterminal angles. So positive coterminal for 5 pi over 6. I want to add a full rotation, which means I'm going to add 2 pi. So 5 pi over 6 plus 2 pi, which when you get a common denominator, that's going to be 12 pi over 6, is going to give you 17 pi over 6. And then I want to find another set, so 17 pi over 6, and that's going to be plus 2 pi. So 17 pi over 6 plus another full rotation, which is going to be 12 pi over 6, which when you add, that's going to give you 29 pi over 6. So there are your two positive coterminal. Now I want to do negative coterminal. So 5 pi over 6, and I'm going to subtract 2 pi. So when I do that, we're going to have 5 pi over 6 minus 2 pi, which is going to translate into 12 pi over 6. So when you subtract, that's going to give you negative 7 pi over 6. So then negative 7 pi over 6 minus another 2 pi. So negative 7 pi over 6 minus 12 pi over 6 is going to give you negative 19 pi over 6. So there are your coterminals and your reference. Okay, so now I would say do 24, and then I'll stop at 24. So with 24, so 4 pi over 3, ask yourself where that one's going to fall. So 4 pi over 3 is going to fall in quadrant 3. It's going to be way over yonder. So when I draw in standard position, my arrow is going to go counterclockwise to the terminal side. And then I want to find the reference angle. So my reference angle is going to be this angle right here. It's always the distance from the x-axis. So to find that value, I'm going to do 4 pi over 3 minus a half rotation. So 4 pi over 3. And then I'm going to subtract a half rotation, which is just pi. So 4 pi over 3 minus 3 pi over 3 which is going to give us a reference angle of pi over 3. And then your positive coterminal, so I'm going to take 4 pi over 3, and I'm going to add 2 pi over 3. Or nope, add 2 pi. So 4 pi over 3, and then I'm going to add 2 pi. So 4 pi over 3 plus 6 pi over 3 when you get a common denominator, which is going to give you 10 pi over 3, which I feel like we already did this one, but that's okay. So 10 pi over 3 plus another 2 pi. I'm going to take a shortcut, which do as I say, not as I do. 16 pi over 3. Okay, and then I'm going to do the negative coterminal, so 4 pi over 3. I'm going to subtract 2 pi. So 4 pi over 3 minus 6 pi over 3, which is going to give you negative 2 pi over 3. And then we're going to subtract my handwriting. Then we're going to subtract another 2 pi. So I'm going to subtract 6 pi over 3, which is going to be negative 8 pi over 3. So, ta-da!